أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين.
Thank you so much, Shami, for the word of prayer. Good afternoon once again. Thank you so much for keeping time. Today, we are going to look at differential equations. However, what we are going to look at, I want you to take, we are not looking at the whole topic, but we are going to just make revision. I know that some of you have not done anything concerning differential equations, but you have done some concepts about differential equations. So we are going to just be doing and reviewing what differential equation is all about. However, differential equations that we are going to look at today, we are going to look at the ones that are modeled already. Then tomorrow, we shall look at how we can model ours. Now, the competence for differential equations requires that you should be in position to model, to come up with your own equation from a problem, that there is a problem that is existing and you are in position to come up with a model, and then you can be able to solve a problem with the model that you have come up with. But also, you must be in position to interpret the solutions that you have obtained. That after solving this particular DE, are you in position to interpret? Are you in position to look at the context that you have and then you come up with a solution? So if yes, then it means that you are in position to predict. Now, differential equations, one of the areas where it is very important, it is in the prediction. That if you want to make any predictions, then it means that these DEs are going to be very key in whatever thing you are going to do. So when it comes to predicting, you want to analyze, you want to make decisions about things that keep on changing over time, then it means that it is the is that can be supportive in that. Therefore, using the knowledge of the is, you can be in position to predict. In case you have a population, you can be able to predict that maybe by 2030, this is the kind of population I'll have in my area or in my school. In case it is in business and you have been receiving customers every day, then you can be able to know that by maybe this time round, I'll have this number of customers. Even if it is in the hospital, when hospitals are planning for the stock of medicine they should have, then what do they use? They look at the patients that have been coming to their hospital, then they can come up with an equation, with the DE equation, that now they can use that maybe in this month of August, these are the number of patients that we shall be expecting. So when they're stocking the kind of medicine or the different medicines they need to have in the stock, then they will use that knowledge and then they are able to make the prediction that we shall need this, we shall need this. You'll notice that during the COVID-19 times, the president used to display graphs, but in order for them to be able to analyze, to know that in this particular area, these are the number of people we have. In this particular area, these are the number of people we have. So that is what we use. They were not counting people like 1, 2, 3, 4. No, they were using mathematics to know that if today we have received 5 cases, that means that by this time, these are the number of patients that we shall be having. So do not think that they were counting 1, 2, 3, 4, 5. No, they were using the equations to predict that these are the number of people that we shall have by this time. Because when you look at the pattern, you study the pattern that today we got 2 cases, tomorrow we have 3, the other day we have 5. Then now that means you can come up with a mathematical model that can help you to predict that by this time, these are the number of sick people we shall be having. But the knowledge that can support you is the knowledge of differential equations. So when it comes to predicting, you want to analyze, you want to make decisions, whatever thing you are doing, even the results you are receiving, you can easily come up with a model to know how you will perform in the next paper. If at least you have 3 of that tests that you have been doing, you can easily tell that in the next test, this is what I think I may come up with. So differential equations are going to be supporting you to understand how things change over time. If there is anything that changes over time, then it means that it is this topic of differential equations that can support you in that. Now, where do we use differential equations in real life? Where can scenarios come from? Now, any of the things that I'm showing here, since they change over time, it means that a differential equation can be set. A scenario can come from any of these. When it comes to population, you know that population changes over time. We can use your schools where you are. You'll find that this year you were 500. The next year you find that now maybe they are 600. The other year they are 1000. That means that those things that change over time, we can use differential equation. So when it comes to population growth, we can have that in differential equation. So a scenario can come when it is talking about population. When it comes to temperature, because the temperature keeps on changing, when you pour hot water in your cup, after some time you'll find that the temperature has decreased. So that means that we can come up with a scenario concerning the temperature change, the time that tea takes to do this and the other. When it comes to medicine and drug absorption, whenever you take medicine, it will be taken in your body, but after some time it will start now killing the germs and the rest of that in the body. So that means that also that one, it takes place, because whenever you take medicine, it takes some time to start what? Acting. And whenever the time passes, you feel that there is what? A change. When it comes to forensics, when it comes to economics and business, in business you can predict depending on how the math has moved. For all businesses that are good, that are very good and are very knowledgeable with what they are doing, they always make prediction. They don't just stock anyhow, that today we shall stock this, today we shall no, they will sit down and say that in the month of January, how many customers did we receive in that month? That we received 50. Then they look at February. How many customers did you receive? Maybe you received 53. In maybe March, how many customers did you receive? Maybe you received what? 40. Then they will start analyzing that in January, which items were bought by the 50 customers that it is in February, and like that. Then they will start now checking out the pattern that this is what now we need to do according to this number of customers. Why did the customers here reduce? Then they can come up with those mathematical models that they can use now to know that in June, these are the number of customers we shall be expecting, and these are the profits, or these are the losses we can make, such that even if they are going to the bank to get a loan for their business, to grow their business, they know that if we are to go to the bank, this is the amount of money we shall need, and even by this month of June, July, we shall have hit this profit, because they know now how many customers visit them, which kind of goods they buy. So they are able to know how their business can work. So that's where that knowledge can support you. Even they can know now the price, that these are the prices for the item by that time. So that's why when it comes to things of finance, when it comes to things of economics, they need someone who has the mathematical knowledge. And those who are doing economics, even at campus, you learn things concerning quantitative economics, whereby you have to have that knowledge about numbers. Then also when it comes to physics, things like radioactive decay, you'll find applications here. When it comes to engineering, you can. When it comes to agriculture, they will. You know very well that whenever you have crops, let me say maize and the rest of that, many times they are attacked by pests. So we can now come up with a model, and we ask you that maybe a given plantation was attacked by maybe this kind of pests. Every day they were eating these leaves, this kind of plants were affected, and the rest of that. So all those things can be set. Now these are some of the areas where you can find a scenario being set. But whenever they set a scenario, always go a step ahead to identify those kind of areas, like real life thing, because many times we are looking at the real life thing. That what is that real life thing that where this knowledge you are learning about can be can be applied. So it is no longer about you calculating the math, but what is the application of the knowledge you are taking away from school. Now, as we got into the differential equations, now you need to know which kind of knowledge will you need. Now, differential equations has a lot of knowledge about calculus. You have done calculus, and what is contained in calculus? You have done things concerning concerning differentiation 1 and differentiation 2. So here you are going to find that you are going to find your differentiation 1 and differentiation 2 applicable. You have done things concerning integration. So you're going to find integration 1, integration 2, or whatever thing you have done in differentiation, integration. You have done trigonometry, that is senior 5, term 1. No, term 2, I think. You have done term 1. You have done something concerning trigonometry. You are going to find application here. You are going to find that you are going to be applying the knowledge of what? Trigonometry here. That means that whatever thing you are going to do, all these areas of differentiation 1, differentiation 2, integration 1, integration 2, trigonometry can be set in one number. It can be one scenario, but where all those things you have learned about are here. So that means that as you approach differential equations, you need to know the different techniques you have learned, that maybe this is integration by this is integration this is integration this. You need to know the application of the knowledge. So that is what we are going to be mainly looking at in this particular topic. Yeah. So I wanted to just give you a brief as we start. So you're going to find that I'm going to be relating to the different topics that time is going to come when we are talking about trigonometry. Time comes when you are talking about differentiation. Time comes when you are talking about integration. So this is going to be our first scenario we are going to look at. Like I've told you, we are going to look at what has been modeled already. And then we are going to look at how we interpret these scenarios, how we go about them, and then from there, we shall be good to go to look at how to model ours. So I'm going to take some time to read through the scenario, Okay, when you finish to read, then go on and go on. After reading through the scenario, you can let me know that now you have finished to read. So we say that you are going to be learning things that change over time. So you know very well, the first one we are looking at here, it is about population. And you know that population changes over time. You'll have births, you'll have deaths. So as some people are dying, others are being born. Now, what do they want us to do? They are asking us that using suitable mathematical model and reasoning, determine an expression describing the fox population after T years. Now, indirectly, they're asking us when you look at this scenario, first identify from this scenario, what does each of these things mean? So you have noticed that you have n, which stands for the number of foxes, how many they are. So this n stands for the number. Then the n means how the number of fox changes with time. That this week there are how many, the other week there are how many, like that. How these foxes change with time. And T stands for the time. Now they want us to find the population. Now that means that N is the one that is what stands for our population. That how many foxes do we have? So that is what we are going to first obtain. So those who don't know the foxes, they look like this. This is their picture and that's how they look like. So now we are going to start. Now, like I've told that in these scenarios, you'll find that you will need a lot of knowledge. Now we are going to use the knowledge of integration somewhere. We are going to find ourselves using the knowledge we acquired from partial fractions. So that means that very many topics are being embedded here. So that's why you need to know all the topics you are covering, because one topic can be found somewhere. So what are they asking us indirectly? That we have our dn, dt is equal to 2n minus n squared. Now, in order for us to get that expression that gives us the number of fox, it means that we need to find what does n stand for, or what is n. We need to find that equation. We need to find that expression that contains n with respect to time. So what are we going to do? Now, we are going to first have this differential equation, but we are going to separate. And when we are separating our variables, we always bring them on one side. Anything with n, let it be on one side. Anything with t, let it be on its own side. So that means that here we are going to come. What has n will come on one side. What has t, it also remains on its own side. So in case you want, even some people can just say like this is out of 1 and then you cross multiply. That one is also very okay, no problem. As long as you don't show it, but you know it in your head, that's what I'm going to do. So for this case, I'm going to set the n out of 2n minus n squared will equal to my dt. So I have taken my dt this side and I've brought my 2n this side. Now, after bringing them, so it's like when you have, let me write here, like when I have the n is equal to the t is equal to maybe 2. What I can do, I can say this is out of 1. Then I cross multiply like this. So I have the n is equal to 2 the t. But since I want 2 this side, I will divide by 2. I divide by 2. So you get the n out of 2 is equal to the t. That's what we are doing literally, such that we can have the n's on their own side and the t on their own side. Now, after separating, since you are interested in getting the n, you are interested in obtaining n, it means that you are going to integrate on both sides. Members, in order for us to remove this d, we have to integrate on both sides. So when we are going to introduce now the integration side. So we shall say now the integral of the n out of the 2n minus n squared will equal to this side the integral of the t. Now, in the chart, I want to tell me, when you look at this kind of integral that we have, which approach, which method of integration are we going to use such that we come up with our answer? Think. Place for me in the chat. What do you think? Which approach do you think we are going to use to come up? Someone is saying natural log. Okay. That is Jonathan. Another one. Okay. Others are still thinking. Okay. Now, when you look at someone is saying lean sign substitution, partial sign substitution. Okay. Now, whenever you find such, the first thing you need to think about is one, much as I know now, some of you, when you looked at the squared, what came to your mind? That is sign substitution. But for sign substitution, it is always better when if it was like this, whereby this is 1 or this is a constant that doesn't change, that is okay. But whenever this variable you have here is a variable that is changing, then don't think about sign substitution as the first option. That is number 1. Yes. Now, what are we going to do? Now, this one will require you to use your knowledge of partial fractions first. So now what am I going to do? I can write this as the n out of, now here the common factor is n. So I write n into 2 minus n will equal to the integral of the t. Now, when you look at what you have, you notice that this is now going to be our integral. But this is now, we can express it in partial fractions first, such that you can be able to integrate well. So you know from your knowledge of partial fractions. Now, you are going to allow me to first extract this. Now, from your knowledge of partial fractions, let me put it here. Now, using partial fractions. So you know very well that now you have 1 out of n into 2 minus n. This is equivalent to a out of n plus your b out of 2 minus n. So what are you going to have? You are going to have this side. Hope everyone knows how to do now partial fractions. So this is going to be this plus b of n, and this side will be equaling to 1. Now, you can open now your brackets and say now, my brackets, I'm going to have my a, but it depends on the approach you want to use here. There is no problem. Some of you may want to say that when my n is equal to 0, that is okay. Some of you want to use another approach, but allow me to use the easy one. So I'm going to come to this second slide, and I say that I have my 1 equivalent to my a into 2 minus n, then plus b of n. Then I say when I'm going to start with n is equal to 0, so I will substitute where there is n, I put 0. So I'll have 1 equaling to a into 2, then plus b times 0. And therefore I'll have 1 is equal to 2a. So I divide by 2, I divide by 2. So meaning that my a is equal to a half. Then I go back. What about when my n is equal to 2? So when n is equal to 2, I'll have 1 is equal to, here I'll have a into 2 minus 2, then plus b times 2. So you end up with 1 is equal to 2b, and therefore your b is also equal to a half. So that is what we are going to have. That means that in our expression, where we have a, we shall put a half. Where we have b, we shall also put a half. Members, let me know through the chat whether we are still on the same page. Are we on the same page? Okay, sure. Okay, let me first, okay, I had seen a hand up. Okay, it's okay. Now, when we go back to our integration we had integral of 1. Now, this was n into 2 minus n, and this was our dn. Now, that means that I'm going to write it because we said that from our partial fraction knowledge, we say that when you have 1 out of n into 2 minus n, we say that this is going to be a out of n, then plus our b out of 2 minus n. That means that we are going to substitute where there is a, we put a half. Where there is b, we put a half. So that means that here you are going to allow me to write 1 out of 2n, then plus our b, which is also 1 out of 2 into 2 minus n. And this is going to be with respect to the n. Now, members, please take note that our a was this out of n. But you know mathematically that this is the same as a half divided by n, which is the same as a half times 1 out of n, which is the same as 1 out of 2n. So that's why here I'm writing 1 out of 2n. Similarly, when I have a half divided by 2 minus n, this is the same as having a half divided by 2 minus n. So which is the same as a half times 1 out of 2 minus n. So which now I can write as 1 out of 2 into 2 minus n. So hope you have taken note of that. So can you use continue to integrate as I answer some questions? Imran?
Good afternoon, sir.
Yes, good afternoon.
I'm sorry to take you back, but I had a little bit come late, and I'm inquiring to know about what we are dealing with and okay, where all this comes from because I'm very lost.
Okay. I'm going to respond, Imran. Yes, Christine?
Good afternoon, teacher.
Yes, good afternoon.
Teacher, I'm requesting you to pardon.
Which part?
Like from partial fractions.
Have you just come in also?
Yes.
Okay. Okay. So, those who have just come in, we are dealing with differential equations, and now we are solving the differential equation that we have at hand. So that's what we are doing. So what we are doing now, we are substituting in for this, where we have this. So when you look at what we have this side, now this is where you can bring in now your knowledge of natural logarithm. So what we have here, you can bring in your knowledge of natural logarithm. So even here, if you want, you can separate and say this is 2 out of n with the n. Then you can also do this, that is the same as a half into 1 out of 2 minus n, the n. And even those who are interested, it is still very okay to have this half taken out such that it can look very nice. 1 out of a, even you can remove that half, and then you get the integral of 1 out of 2 minus n with respect to n. That is very, very okay. So can we integrate that? Can we integrate that? Tell me, what do you get when you use natural log? Integrate, I want to see. User has said that here you are going to remain with a half natural log of n. Good. Plus this side, I want to see people integrating. Integrate for me the second. There is something interesting I want to look at for the second part. We are integrating this. What do you get when you integrate that? Negative ln. Okay, thank you, Shinaz. So, members, when you have this integral of 1 out of 2 minus n, the n, what do you do? Now, when you have this, you can let me just use this side work. You can let and say that let your u equals to 2 minus n. Then you say that what do you have here? This is the u is equal to, when you differentiate this, you get negative 1 the n. That means that when I come back here, I'll have an integral of 1 out of, where there is 2 minus n, I put u. So this is going to be u. Then times, what is the n? When you come here, your dn is going to be negative du. So that means I'm going to have negative 1 out of u with respect to du. So when you integrate this, you get negative ln of u. But what was your u? Your u was 2 minus n. So I'll have 2 minus n. So this is what you get. Once you integrate this is what you remain with. Now, what mistake am I noticing? Some of you forgot to put a negative. Some of you were putting a quarter, which is not true. So that make sure that once you differentiate this, that the result you have got, you can be able to get back to the first thing. So here I'm going to come, I have my half here already. So I'll say this is a half, then times this negative 1 we have obtained, then, okay, natural log of 2 minus n, then plus c. So which now I can write in a good way as a half ln of natural log of n. This is going to be minus a half ln of natural log of 2 minus n, then plus a constant. So that is what we are going to have on our left-hand side. Okay, so yes, Juliet, and then Doreen.
Good afternoon, sir.
Yes, good afternoon.
Sir, may I was why are you using the natural log to
Natural
differentiate?
log. Have you integrated this before? Have you ever integrated 1 out of x with respect to the x?
Yes,
What do you get?
we get x inverse. Yes,
You get?
x inverse.
You get x inverse, the x,
Then we get negative x
You get?
integral of negative x.
No, integrate. What do you have? That's what I want.
You want the answer direct?
Yes. Mhm. So you note that here you cannot integrate because the moment you do like this, you note that down you are going to have a 0, which is not
Yes.
true. So whenever you meet such, that's when you get the natural log of x.
You just introduce the number directly.
Y- Yes, but you can review. We did this, I think it was early this year. We looked at it.
Okay. Thank you,
Yeah,
sir.
yeah. Juliet,
Yes?
question? Your hand was up.
No, it's thank you, sir.
Okay. Yes. So why are we using the magnitude? I told you that magnitude means that you can never have a natural log of a negative. So that's why we are bringing in that. So I'm going to go back to the first screen. So that means that where I have this, we are going to place that. But now this side here, when you look at what we have on our left, we have here an unhidden one. So when you integrate this, you end up with the t, then plus a constant. So you are going to allow me now to, I don't know if I have a space here. You are going to allow me now to say that when our integral that we had of the n out of everything here was n, out of 2 minus n, which was equal to the integral of the t. Since we have finished to integrate here, we have obtained our answers a half ln, this was magnitude of n, minus 1 out of 2 integral, this was 2 minus n will equal to t, then plus a constant. Now, since you have done logarithm before, you can also have this one written in a simpler form. How are you going to write it? A half and a half is common, so you can factor it out. So when you factor it out, you remain with the ln of the natural of n minus ln of 2 minus n, then is equal to t plus c. But you know that from your logarithms, whenever you have log that have the same base and you are subtracting log a minus log of b, this one is going to always be division. So you have a out of b. So we are going to apply the same, that since this is subtraction of logarithms, we are going to divide. So you are going to allow me to clear my screen, and I say that this is going to be a half ln. Then I write my magnitude of n out of 2 minus n is equal to t, then plus our constant, which is c. So what am I going to do next? Now, when you look at the question, they gave us the initial conditions. So when you go back, they told us that at the beginning of the study, in the chat, you tell me if they tell us that at the beginning of the study, what is going to be our time and what is going to be our n? Put for me in the chat. At the beginning of the study, what is going to be your time and what's going to be your n? So, our time is going to be 0. Very good. What about n? What about n? What about n now? Good. Good. Thank you. Yes, so they told us that at the beginning of the study, it was estimated that 1,000 folks were living within the urban area. The researchers wanted to use the model to predict how the fox population would change over time and to assess the long-term sustainability of the population within the city. So now that one you need to know it. Now, I want to let you know that we are going to have our n. I'm going to take our n since you know that it is 1,000. So we are going to work out our model in thousands. So our n, I'm going to write it our n, but our n is going to be in thousands. So our n is going to be 1. So when it is 1, since we are working in thousands, it means it will be, because they told that n is measured in thousands. Now you read here, n is measured in thousands. So that means that when n is equal to 1, it means 1,000, 1,000. I don't know whether now you have understood that. Have you understood that concept now? You need to first read the item, what the scenario is saying. So they told that n is measured in thousands. So that means that when I write n is equal to 1, it means that that is already 1,000, which is equivalent to the initial that was present at the start. So it does not mean that you are going to say n is equal to 1,000. Have you understood that before we continue? James has said yes. Has everyone picked that? Yes. So before you rush to put the 1,000, you need first understand to read what are the units for that particular variable that you want to work with. So I'm going to come back here and I say that when n is equal to 1, our t will equal to 0. So we substitute. So we shall have a half natural log of n, which is 1, out of 2 minus 1 is equal to t, which is 0 plus c. So this is going to give us a half ln 2 minus 1, which is ln 1, is equal to 0 plus our c. So what is going to happen? You ask yourself, what is ln of 1? Can you have ln of 1? It is equal to 0. So what will it mean? It means that because ln of 1 is 0, so you shall end up with 0 is equal to c. That means that your c is equal to 0. Now, after getting the 0, now I'm going to go back and I substitute in this equation where there is c, I put 0. So that means that we shall have 1 out of 2 ln of n out of 2 minus n is equal to t. But since we are interested in n, we are interested in finding how n, this population, varies with time, I can remove these 2. So to remove these 2, I can multiply this side by 2, I multiply this side by 2. So once I multiply, it means that I'll have my natural log of n out of 2 minus n is equal to 2t. But you know very well that natural log means log of e with respect to e. Now is going to be of n out of 2 minus n is equal to t. Now you go back from your knowledge of logarithms that if I have log of ab is equal to c, from your log that you studied in term 1, this is the same as b equaling to a power of c. Now here, it means that our e is going to come here. So that means that your equation is going to be n out of the 2 minus the n equaling to e power of 2 to t. Now, what are you interested in? So what are you interested in is the n. So that means you can say now n will equal to 2 minus n, then everything we are multiplying by the 2t. So when you open up the bracket, you can have n is equal to 2 of e 2t minus n of e 2t. But remember, when you want to express one variable in terms of the other, always that variable must be on its own side alone. So anything with n must be on its own side. So we are going to take this one, the other side. So since it is a minus, this side it will become a plus. So we shall say n plus ne to t will equal to 2e to t. But you notice that n and n are common. Now since they are common, you can factor them out. So you shall have n into 1 plus e to t is equal to 2e to t. But what are you interested in? You are interested in n. So since you are interested in n, you are going to divide throughout. You are going to divide through by what is on both sides. So that means that your n is going to equal to 2e to t out of 1 plus e to t. And now this is our population that is written in terms of the of the time. That t is the time and then n is the population that is present at that time. So when you look at it, you can test it out. You know that initially when your population, when your time was 0, this was 0. So what was the population present? It was 2e power 0 out of 1 plus e to power 0. E power 0 is 1, so this means it is 2. 1 plus e power 0 is 1, so this is 1 plus 1, which is 2 out of 2, which is 1. That means that initially, when the time was 0, you had 1. But this n is in thousands, so that means it is 1 times 1,000, which is 1,000 folks that are available. So that is how you write your part. Whenever they tell you to express, now that is how you can express it. So I'm going to have only 2 hands. Yes, is it Isaac? And then Doreen.
Teacher,
Yes,
good afternoon, sir.
good afternoon.
Somehow I'm here where you're saying log of base n out of 2 minus n equals 2t. I'm feeling where you're getting this log base e.
No, like when you have lean is the same as log base e.
Oh,
You looked at that in logarithm.
yeah, I recall. Yeah.
Okay. Yes, Melissa?
So I'm actually lost from here. We stopped at the C, the other side of the lines. Where is the C this side of T? Where you getting me?
No, like at this step, are you seeing at this step? It is okay. Now, but I decided to put C this side because also this side I would have gotten C. Because whenever you integrate, you put a constant of what? Integration. But now I have put integration on the time constant. This side where I have time. So this C caters for both the constant this side and the other side.
So it's a must for me to put it this side where T is.
Alright, okay, it is better that side than you having it the other side of N. But at the end, you get the same things as well.
Okay,
Even
thank you.
if you had put it here, I think as long as you don't put 2 C's, because like when you have 2 plus x is equal to maybe y plus 4. Like these 4 and the 2 are constants. So you can decide to put them on one side. So I can decide to take it this side and I say x is equal to y plus 4 minus 2. So 4 minus 2, you will get y plus 2, which is a constant. Now, the constant of this side, let me say C1, and the constant of this side, once I combine those two, I get 1C.
Oh, thank you.
Okay. All right. So, members, that is how you... Okay. So, that is how you deal with that part. Now, we go to the next part. So when you go to the next part, they wanted us, so that was the first part here at after time t. Then they told us to investigate how the population changes as time increases. Now, in order for you to investigate that, you are going to ask yourself, what happens as the time is increasing? So the first time, like we have said that when t, so now your investigation, you are going to increase the time. When time is is 0, you know that your n is equal to 1. When time is equal to 1, what is your n? Get it? When time is equal to 2, what is your n? When time is equal to 3, what is your n? So like as the number of years keep on increasing, what do you observe about n? Can we everyone now start punching in? Allow me that for me, I'm going to have it on, okay. I'm going to have it here on the graph to show you how it is going to behave. So this is going to be my n. But for you members, you can keep placing the calc and this is the time because I want to know the kind of relation and the behavior. So when I put in t is equal to 1, so can you place it in the calc? Allow me also to place it here on my calc, as also you place it there, and then we agree. Those who know how to place it on the calc, you can place everything here at the same time on the calc. This is what I'm getting. Eh, keep on placing as the time increases and then see how does the n behave. Place. And you tell me. I'm going to do some kind of plotting here to show you that kind of what? Of behavior. Oh, okay. I want to show you the behavior such that you know now, because we have said that you must be able to interpret whatever result you come up with. So this is 4, this is 5, this is going to be 0. Okay. So place, you can have as many values. This one I'm going to put 1, I'm going to put 2, I'm going to put 3, I'm going to put 4. So I'm going to start plotting 0 and 1. 0 and 1 is here. I go to 1 and 1.7. 1.7 is going to be somewhere here. I go to 2 and 1.9 is here. I go to 3 and 1.9 is here. I go to 4 and something is somewhere here. Continue. This is 2, but I want to put a straight line here at 2 just to show you such that we are very sure. So place. Okay. What are you not seeing? Okay. No. Now, Faith, I want, like, you need to know that the C you are looking at, the C of this side, the constant, can't be the same C with this side. So this C is C1 and this one I've told you it is C2. These two integrations things, they can't have the same constant. So if you bring this constant this side, you'll have C2 minus C1. Now this C2 minus C1 is what we are calling now the one constant of integration. That's what we are saying. It's not that this is C and this is C. No. In fact, even for your integration side, it's not a must that it's supposed to be C. When you start reading, you'll find that even in some books, they use K. Yeah. Yes. So that's where I want you to understand. Yeah. how it comes about. And I've told that constant means a number, a digit. Like 2, 4, like I showed you that when I was showing the other girl, I showed her how you can have 2 this side and 4. But when you have 2 and 4, you can combine them into one digit. And that digit can qualify to be called a constant. Okay, hope you have understood. No, Doreen is standing for the time. You just keep on saying that this is the first year, second year, third year. How many animals will you have? That's what we are trying to do. Uh-huh. Wait. Okay. Very good. I think now people are starting to notice that you notice that there is not any value you are going to put for T. Here, there is not any value you are going to put for T, and your answer goes beyond the 2. I don't know that members are noticing that. There is no any value you are getting for 2. You are putting beyond, even if it is 1,000. I don't know that members are noticing that the value is you are not going to reach there. So that means that your curve is going to look like this. And now, can I ask you, you did curve sketching. You did curve sketching. Which kind of behavior is this? Those who remember. Hey, how do you call this kind of behavior? You have got a math error. Yes, that's when you have reached 1,000. So we can call it is asymptotic. Very good. Yes. So you'll find that your curve is here, but it is when you reach some point that you get up to 2. So your curve will reach the 2 and it will stop there. Whatever point you are putting, it means that your value has stopped. Now, when you come here, when you come to your investigation, when you come here to investigate how the population changes as time increases, looking at the graph you have, then you can now describe what are you not seeing. Who is going to describe for us? Henry, are you describing for us? Are you telling us how the population changes with time? Oh, Henry. Yes, Henry?
Yes, yes. For this is what I would say that for as time increases from 0 to 6, the population becomes constant. Then beyond 6, it remains constant.
They will?
Like the time when the time moves from 0 to 6,
Hmm.
it the population becomes some constant value. Then beyond 6, the time when
Mm-hmm.
it extends beyond 6, it
Mm-hmm.
retains that constant value.
Okay. But
But sir,
okay, good.
I have a question, sir.
Yes.
You said that that behavior would be asymptotic to that carrying out
Up to
time
some
t.
point, up to some point,
Yeah, it would be touching it somewhere.
up to some point. But when it reaches 2, then it will be touching somewhere. But also, okay, yeah, it will be touching somewhere. Okay. But hope you know that there are some asymptotes that are attached. Have you heard about it? There are some asymptotes that your curve can cross. Hope you have learned about that behavior in curve sketching. Yeah. So asymptotic does not mean that the curve cannot touch. No, that is not the meaning. But you are looking at how the curve behaves as it approaches that given what? That given line. Yes. But it does not mean that the curve does not touch something. Because I know if you have done curve sketching, you have reached where some asymptotes are being crossed. Okay, so that's how you can describe. You look at your time and you look at your n and you check how they behave. Okay. Yes, Fiona? Okay. So that is how you can approach. Now we go to the hence part. Hence comment on the long-term behavior of the fox population predicted by the model. Now we are asking, now when we talk about long term, here they are asking you that after a very long period of time, here members have noticed that once you reach, I don't know which part people reached, but they reached somewhere and things were turning out to be 2, whatever value we are putting. Now what does it mean? What does it mean? I think, let me be sure. I think when you reached a given value, you notice that what you are getting was maximum. So what does it mean? When you have our curve, when you look at the expression that we got, I come back here. I'm going to come here. You notice that your population N depends on the time. So your population is dependent on this E. It is dependent on this. It is depending on what? On E to T. This is what your population is depending on. For your population to change, that means that this this exponential of T must change. But you have noticed that this exponential of ours has a maximum value. That this curve of ours has a maximum value beyond which you cannot exceed. Like you have seen that when we have drawn, we cannot exceed a value of 2. I don't know the members notice that. That means that E2 has a maximum. So that maximum value is 2. That means that this curve of this population of ours is going to have a maximum of 2. So your n cannot exceed beyond what? 2, because that is the maximum value. Like when you looked at the graph, what you are coming up with, you notice that you could not exceed 2. That means that the highest population you can attain is what? When n is equal to 2. Now, if you do not use this approach, like the approach we have used of investigating, you put in, and you see what is the maximum value of n you can obtain, you could as well use the second approach. Now, the second approach will mean that you need to know the behavior. That as time, when we talk about long time, here we are looking at what happens as t tends to infinity. That is the thing. What happens when t is tending towards what? Infinity. Now here you notice that the time varying thing is this e to t. So what can I do? I can say this is 2 e to t divided by e to t out of 1 out of e to t plus e to t out of e to t. Now e to t out of this, you remain with the 2. Out of 1 out of e to t, then plus the 1. Now you know that when you have 1 out of e to t, remember now you're going to have 1 divided by e to t. But we have said time is tending to infinity because you are looking at a long time thing. So that means that when you have e of a very big number, let me say 1 million here, the answer you get is a very big thing as well. So that means that 1 divided by a very big number. What is your answer? Since you have done numerical methods, which answer do you get? Which answer do you get from your numerical methods? Thank you, Martina. Thank you, Henry. So the answer here is approximately what? 0. So that means that where there is this 1 out of E2, everything vanishes to 0. So that means you can write 2 out of 0 plus 1, which is the same as 2 out of 1, which is the 2. So that is the 2 we were getting, whereby you were not going beyond 2. So that is the other option that you can use. So that is how we can obtain. So for this part where they told us, hence comment on the long-term behavior of the fox population predicted by the model. Now that means that since we have got that the maximum population that these fox can go to is what? Is 2. That means, and remember we said that n is in thousands. So that means you set 2 times the 1,000 and then you say this is 2,000. That means that when you are commenting on the long-term behavior, you are not saying that these folks are going to grow. As they are growing, the number is increasing. Time is going to reach when they are maximum, when they cannot go beyond 2,000. That initially they are going to be increasing, but after a given period of time, the population is going to become stable, that there is nothing. That means that those who are that are dying and are born are the same, because now here they are fighting for, remember they told you that they are looking at it was about space, shelter, and food. That means that now they have to fight for those things. So the population is going to maximize. So that's how you can look at the commenting on the long-term what? Long-term what? Behavior. Yes. So you can, in case you are explaining, you can say that maybe the model is predicting the fox population to increase over time. Over time, then you say that, however, the rate of growth gradually becomes slow, and in the long run, it stabilizes to 2,000. Then that's how you can explain that. So that's how you can comment. Now that's why now you need to know, how do you interpret? You are not saying that here now you are bringing in your knowledge you learned from the numerical methods, that it's going to be applied here. The differentiation you learned is here. You learned about curve sketching is here. So that is how now you can relate the different topics that you are learning. Okay. Any questions? Or we are good to go? Are we good to go? Kindly let me know through the chat whether now we can continue. Okay. So people are saying we are good to go. Okay. Let's look at another scenario. So you read through. Okay. Hope the question is there. Members, are you seeing the question? Okay, perfect. Are we good to start? Okay. Now, what are we going to do? Now, still, whenever you get these models, first look at it, because when it comes to differential equations, they can give you the equation when they have formed it already, and now they want you to interpret it. So they are telling us that engineers at one of the parks are testing the wave generation machine, you know that we have in swimming pools, sometimes they put there those things that generate the waves. Even you have seen those who are farmers in fish farming, in case you want to have maybe the water to keep on flowing, what, sometimes they put those instruments that can keep on making the water flow as if it is a river. Now, they are telling us that X is representing the height. Now, here you need to ask yourself, how does a wave move? In senior 4, you looked at waves. It doesn't mean that you must be doing physics at A level. So you need to know that how does a wave move? That a wave is like this. That is how a wave moves. So what does it mean? It means that X represents the height of the wave above the reference level at time t. Meaning that if this is your wave, and this is maybe your reference thing, that means that this is what we call our X. That is like the height, because we have a reference point. Then they went on and said that and t represents the time. From the experimental observation, they have discovered that the rate at which the height changes is proportional to both the current wave height and then the oscillating motion. Now, this is what they have given us. What do they want us to find? They want us to determine what kind of relation is existing between the height, remember height is what we have as our x, and the time is here. What does it mean? They are indirectly asking us, can we form an equation? Can we form an equation that is relating x and t? That means that they don't want us to have these rates of what? Of change. So that is now what we are going to be working on. So still, it means that for you to be able to do this, you need your knowledge of what? Of integration. So when I come here, I'm going to first separate the variables. So I'll say the x, the t is equal to 2x sine of 2t. When you see this, this is the domain. This one we call it the domain. That they are telling you that your time can never be a negative. That is the implication. Yes, that is the meaning. That time cannot be a negative. So you are going to separate. Have the x on one side, have the t's on one side. So I can decide to have that this is the x out of x is equal to 2 sine of 2t with respect to dt. Members, is that step fine? Is that step fine where we are now to everyone? I've taken the dt the other side, take the dt the other side, bring the x this side. I repeat, you have the x is like, okay, you have the x dt equaling to 2x sine of 2t. Now you can first do your cross multiplying. So you have the x is equal to 2x sine of 2t with respect to dt. Now, what do I want? I want to remove the x. It is okay. If you want, bring the 2x the other side. There is no problem. For you, whatever you want. So I want to remove the x this side. I want to remove the x. So that means you get the x out of x is equal to 2 sine of 2t with respect to t. You can bring that 2. This is math. Whatever thing you want can work out the other way around. Even if you decide to bring 2x, it is okay. Even if you leave it the other side, it is okay. It will work out the other way around. So what do you prefer, members? Tell me in the chat. Should we bring the 2x this side? We leave it. We can work out with whatever you want. Okay. Yeah. Okay. Okay. Now, those who want to bring it, please bring it. We shall get the same thing. Now, the next thing we are going to do is we are going to integrate. So when you integrate the x out of x, this is ln of x is equal to, when you integrate this, now you need to integrate sine. So here, let me just write. So this is 2 sine of 2t with respect to dt. Now those who want, you can first come and say, my angle is 2t. So I said that let u equals to 2t. Then you say, what is this? This means du is equal to 2 dt. So since I want dt is going to be du out of 2. Now I'll come back here and I substitute. I have 2 sine. Where I have 2t, I'll put u. Then times dt, which is du out of 2. So this 2 and this one cancels. So I remain with integral of sine of u du. And then I ask myself, when I integrate sine of u, what do I get? That I end up with negative cos of u plus a constant. But what is my u? My u is 2t. So I end up with negative cos of 2t. Hope that is okay. So wherever I have the whole of this, I'm going to just put negative cos of 2t. So allow me now to remove it, and I say that here now I'll put negative. It's going to be negative cos of 2t, then plus a constant. Yeah. So now from here, we are going now to start applying our initial conditions. So they told us that at the instant the machine switched on, t is equal to 0 and the wave height was 6. So you'll come here and say that when x was 6 centimeters, our time was 0. So where there is t, you put 0. Where there is x, you put 6. So that means we shall have ln of 6 is equal to negative cos of 2 times 0 plus c. Now, what mistake do we always make? Many of you, what you do, the moment you see 0, you conclude very fast that this is 0. First go on and calculate. So this is ln of 6 equaling to negative cos of 0. Because you know that cos of 0, you can get an answer. So you have ln of 6 is equal to, when you get a cos of 0 is negative 1 plus the c. So since you want c, take the 1 this side. So I write 1 plus the natural log of 6, which I can put the magnitude will equal to c. So that is what we have as our c. In case you have a question here, you may also ask. I don't take it that always my c must always be 0. No. Not all times your c will equal to 0. Your c can vary depending on the situation and the initial conditions. Yes, right.
Yes, teacher.
Yes.
Teacher, thanks for the lecture. Teacher,
Yes.
yeah, thanks for so far so good. But I think any negative cos of any angle is always a positive.
Why do you think so?
And it's what we are taught, that any negative cos of an angle is always a positive, but you're putting negative 1.
Negative?
1.
Where is the negative 1?
There after negative cos 0, I think we are to get like positive 1, but you've put negative 1.
Now, do you have your calculator?
No, I was not holding it even.
Because now what you need to know, cos of
Yeah,
negative 20, I'm just giving an example. Cos of
yes.
negative 20 is not the same thing as negative cos of 20, if this is what you wanted to mean. These are totally different things.
Okay. Okay,
Two,
thank
don't go. Don't go. When you look
you. I'm still,
here, the negative is outside the cos. It's not inside the cos.
yeah, I get.
Okay.
Okay, thanks.
Okay. Doreen? Doreen? Okay. So,
Teacher,
yes?
if I want like to find the constant C, can I put in the calculator and find it in decimals?
No. Actually, here matters.
Okay.
Eh. Okay. Okay. So, where there is C, we are going to replace. So, we are going to have ln of x is equal to negative cos of 2t plus 1 plus ln of 6. Now, what are we going to do? We are going to collect like terms. Now, this ln, we can bring it this side and we make our work look a bit much beautiful. So, we are going to have ln of x. Remember, this side it was negative cos of 2t plus 1 plus ln of 6. Even if here now we don't put the magnitude on the ln since it was already. So when I take it this side, I'll have ln of x minus ln of 6 is equal to, you are going to allow me here, I have negative cos of 2t plus 1. But since I can write this in a better way by starting with a positive and then I write like this. Hope you'll be able to get that. I can start with a positive and then I bring the negative later. Then here, when you look at your laws of indices, this is the same as x out of 6 because you are dividing. Yes, Fiona? Okay, so what are we going to do now? So we are going to have here natural log of x out of 6 is equal to 1 minus cos of 2t. But like we have already said, that natural log is the same as log base e of x out of 6 equaling to 1 minus cos of 2t. Now, take the other side by using the law. This law is going to be helping you a lot. So make sure you know it, that now b is equal to a power what? A power c. That law is going to be helping you a lot. So we are going to end up with x out of 6 equaling to e, then 1 minus cos of 2t. Since we are interested in finding out the model of x, now we shall say that x is equal to 6e 1 minus cos of 2t. So now that is how our model is going to look like. In case, depending on the textbook, I repeat, depending on the textbook, you read not a pamphlet, you may find them writing it in this term. Writing x in terms of t is equal to 6e 1 minus cos of 2t. Let it never confuse you. This is like, you remember your functions in senior 4. When they write f of x is equal to 1 minus 2x, it means that what they have written it in terms of x. So when you find a book, when they have written it like this, it means that your x has been written in terms of t. Okay. So let me first pick a hand. Yes, Henry?
So why don't you take that negative 4 cos 2t down?
Come again?
That power of negative cos 2t.
Hmm. What?
Can we take it
I'm
down?
not.
Like, can we take it? Can we take it down to be 1 out of e cos 2t?
It is okay. You can complicate it the way you want. You can say e power 1 times e power negative cos of 2t. Then you can continue and say this is 6e out of e cos of 2t. You can write your answer like that.
Okay.
Hope that is okay. Okay. Now, Fiona, I failed to get you. Your hand is up, but you are not talking.
Excuse me, sir.
Yes.
Teacher, I'm asking
Yes.
that when we've integrated sine 2x,
Hmm.
why haven't we got negative a half cos 2x?
That is what we have got. But because I used the first principles, here there was a 2. So that a half you get, the negative a half cos of 2t, cancels with this 2 here.
Okay. Thank
Yeah.
you, sir.
Okay. Okay. Now, members, we continue. So that was the relation they wanted between the wave height of the wave and the time. Then they went on and told us that hence determine whether the machine can produce waves higher than 16.5. Can I first get your opinions? whether the machine can produce waves that are higher than 16.5. What do you think we have to do here? Anyone with an idea? Yes, because, Henry?
I think we're going to find the maximum value of that
Uh-huh,
function.
uh-huh.
Yeah, and check if it is 6, if it is set for that value 16.5 or it is less. We get
Okay,
yes.
very good. So, thank you, Henry. We are going to find the maximum value. In the chat, you place for me, how shall we get the maximum value? Yes, Lillian. Placed in the chat. Yes, Lillian. Okay. Now, okay, as I look through the chat, I want to see what we were taught. Okay. Differentiate and equate to 0, you differentiate. Okay. Now, from today onwards, I want to let you know that, okay, suppose you equate the original thing to 0. Okay, very good. Okay, I've seen what you have. Now, when you look at the equation you have here, this is your x, and this is this thing. Now, your x, our height, for our height to change, it will always depend on one thing. It's going to depend on this variable here. For our height to change, it will always depend on this cos, because it is the cos that has the time. That's where our thing depends. You know very well when you were learning trigonometry, I know your teachers taught you about trigonometry, and one of the thing was you must draw the trig curves. So you came up with a trigonometric function of cos. And in the chat, you tell me what was the maximum value of a cos and what was the minimum value of a cos. Put in the chat. What was the maximum value? What did your teachers tell you? That the maximum is 1 and the minimum value is always negative 1. So that means, remember here we are looking at a wave. That means that the minimum value for a cos, and that is for a cos, when the value here is t. It means that here you have negative 1 and the biggest value you can ever go to for, okay, is what? 1. Now you are going to ask yourself, I want to let you know that understanding here is very key. Here there is nothing like cram work. Now what does it mean? It means that since you are dealing with a course whose maximum is 1, that means that the highest the course can attain is 1, and the minimum value the course can attain is negative what? Is a negative 1. So what am I going to do? So when I come here, members, where I have my 1, hope we are there, minus cos of 2t, I'm asking myself, because this is what determines the value of x, whether it's going to go beyond that or no. So that means that you are going to ask yourself, what is the maximum value this function can take on? What is the minimum value this function can take on? Now, if you are to find out the maximum, remember everything depends on the cos of what? 2t. So when we start, when we put in the smallest value cos can attain, you note that cos can attain the smallest value as negative 1. So we shall have 1 minus, where there is cos, we put the smallest value cos can attain, which is negative 1. So from your math, this is 1 plus 1, which is 2. When you put the maximum value cos can attain, it's going to be 1 minus cos can attain the smallest value as 1, which is 0. I don't know whether you're understanding. That means that this function of ours of 1 minus cos 2t, the maximum value, if I'm to draw the curve, I will have here, it will be 0, and here, because you are noticing that you have 0 and 2, it means that you'll have a 0 and you'll have 2. So your curve is going to be oscillating, like it's going to have its minimum at 0 and maximum is going to be at around where you have 2. Now, after attaining that, this is understanding. So after knowing that the maximum value my 1 cos of 2t can take on, it is between 0 less than, I'm going now to write it in the mathematical way, 0 less than 1 minus cos of 2t less than or equal to my 2. That is the meaning. That the smallest value you can go, it means it is 0. In other words, this thing here, the smallest value you can ever put here is 0. Otherwise, if you put anything that is less than 0, you are not going to get any answer. That is the meaning. I don't know whether members now are understanding. The moment you put anything, that means that you are going not to get any answer that is going to make sense. That's what you need now to take note of that. Why? Okay, I don't know whether we are there. So when that means that the smallest now is going to be 0 and the maximum is going to be 2. That means that you can never find here, you are not going to get any value here that is less than 0. In other words, you cannot have anything. There's nothing you're going to put here and you get your answer as a negative. Hope members we are on the same page. Have you understood that? Have you understood? This is now understanding. I told you now we need to look at interpreting. It's not about solving, but can you make sense from what you have got? Now here we are applying knowledge. You are applying your knowledge that you attained from trigonometry. When you are looking at trigonometry, you looked at trigonometry, you looked at how to sketch those curves, and you were told that cos and sine can never have any value that is above 1 or below negative 1. That one you know it already. You can never place your calculator, any sine of anything or cos of anything, and you get an answer above 1 or below negative 1. Okay, so now we are going to continue. So since here you have noticed that the maximum value, that here the minimum value is 0 less or equal to 1 minus cos of 2t less than or equal to 2. That means that here the maximum value we can ever attain is 2. The biggest value, whatever value of t you put here, it should be 2. That is what now you need to know. If you put anything beyond that, then you are going to be in trouble. You are going to be in what? In trouble. That is what you needed to know about that. I don't know whether members are getting that. So what are you going to do? Now, after knowing that the maximum is 2, it means that what is going to be the maximum height our wave can go to. So that means I'm going to say x is equal to 6e. Because this value here can be 2, I'll put here my 2. Because that is the maximum value you can ever get up there. So that means that now you are going to place your calc 6, then you place what is e of 2. So you say e of 2 is the same as times here 7.389. And then you can place now your calc times 6 and you'll end up with 44.334. And this is your height, the maximum height you can ever attain. Let me hope that is okay. In case you are to find, in case the question had asked you for the minimum, then that means that here, the minimum we have said is going now to be 0. So you will say x is equal to 6. Here, the minimum can be 0. So you say e power 0. And therefore, it can be 6. Hope now you have understood. Okay. Yes. So now that's why I said you need to know how to interpret. It's not about now calculating. Yes, Sharon.
Teacher, I'm
Yes.
kind of confused of why we use the power of E, like to get, I don't know, is it to get the intervals?
The intervals, because you know that the height, the wave, remember this is a wave. You know it, right?
Yes, teacher.
The wave, its height depends on this function of 1 minus cos 2t. You know, a wave is modeled by these cos or sine curves. So that means that for any shape of the wave you are going to get, it's going to be dependent on this function here.
Oh.
Yes, so that's why now we need to know that if that wave is moving, what is the maximum it can attain? To bring this out
Okay.
further, you can go on. Are you getting? You can go
Yes,
on
teacher.
and draw this. You can go on. Those who want to draw, you can go on and draw. You can go and say, for me, I want to draw. So you go, you create your table, you have your X, you have your T, the time, whatever thing. Or you have your T here. Let me do like this. You have your T here and you have your X. Then you start putting when T is 0, when T is 1, when T is 2, like that. And then you'll see.
Mm.
Yeah.
Thank you, teacher.
All right. And let me hope that members know that now when you are dealing with such, your calc should be in radians. Take note of that. Your calc should be in what? In radians. Otherwise, if it's not in radians, you are... Yes. Okay. Yes, Lydian? Okay. So, members, I think you have understood that. Okay. So, we are going to continue. Regan?
Yes, teacher. So good afternoon.
Yes. Good afternoon.
I wanted to inquire if it is possible that maybe what we are dealing with depends on more than one like variable. You see, in this case, in these two cases which you have given us, I have been seeing that
Hmm.
in the first case we were dealing with one variable depending on the other. Then also in this case it is the same thing. X is
Hmm.
depending on t alone. But what if
Hmm.
x is not only depending on t? How do you find the maximum and minimum of such? If,
Now, that is not at your level. But when you go, you are going to learn we have the is at advanced levels, where you can have more than two variables, depending. But at this level, you only deal with two.
oh, okay.
You can only deal with two. But in a case, you find that it is on more than two. If you attended the lesson we had on parametric, convert those parametric things into two variables.
Excuse
Convert them into
me, teacher.
Cartesian, and then you can continue.
I'm kind of confused why you have chosen to use 0 and 2.
So, Regan, have you got that? Is it Regan?
Yes, yes, thank you.
Yes. Convert those equations into a Cartesian equation, and then now you can solve. Lydian, we have decided to use 0 and 2 because I have explained to you that cos has a maximum of 1 and it has a minimum of -1. So the highest value would ever, whatever cos you place inside your calc, the highest value you can get cannot be beyond what? 1. Whatever thing you place, whether it is cos of 3,000 or whatever thing you place here. So that means that this cos of 2t, like I've said, it has a minimum. Cos of 2t has a minimum of -1 and has a maximum of 1. Whatever angle you place here, even if it is 1 million, your answer would never go below -1 and 1. But since you have 1 minus cos 2t, now we are asking ourselves, now what can we, such that we get the value? So that is where we have gotten that 2 and a -1. So that means that when you come here in 1 minus cos of 2t, we have said that the smallest value you can ever get is -1. So it is 1 minus -1, which gives you a 2. The highest value you can ever get is a 2. So that means that cos 2 has a, so you say 1 minus 1, which is 0. So that's where we are getting. So that means that this function of 1 minus cos of 2 can have 2 as the because you reason out 2 and 0, which one is bigger? That 2. So that means that your domain is going to be between 0 and 2. Okay. Allow me that now we continue. Tan, you know that tan is, we call it, you know that tan goes like this, eh? So tan goes up to infinity and negative infinity. So you have to just, we get the same answer. What, like, why are we turning our calc in what? In degrees or in radians, eh? Because as I told you earlier on that whatever thing you have here, if they have not put degrees, you have to take note that it is in radians. Whenever you find cos of 2t, whenever you find sine of anything, as long as they have not told you that these are degrees, then you have to calculate in radians. Hope that is okay. Yeah. Okay, so we are going to continue. So let's look at one more. Read through that. So someone was saying that this is Martina. Teacher, we get the same answer even if the calculator is set in degrees. So Martina, you can have your hand. I give you, you tell us what you are getting.
Teacher, I have
Uh-huh.
answered my question because I changed I first did it when the calculator was in degrees and I was getting
Mm-hmm.
my maximum height as 44.334. But
Mm-hmm.
when I changed it to radians, I was seeing that I was also getting the same answer, but you have been able to answer me.
Okay, but first tell you what mode is your calc?
I changed it back to degrees, so it's in degrees now.
Okay, what is cos 4? You tell us what is cos 4 in without radians. What do you have?
Cos 4 is 0.99756.
Take your calc to radians and you tell us what you get. The same thing, of cos of 4.
Cos 4 with radians is negative 0.65364.
Okay. So are they the same answers?
No.
Okay. So let me oppose some because you have got that. Yeah. For some angles, for some angles, they can coincide and you get the same what answer, but not all. Not all. Yeah. So please take note of that. Not all. But some they may coincide and you see as if you are getting the same answer. But if you go with that mindset that you get the same answer, yeah, it will be bad. Oh, yeah. Eh. So is it Davik? Davik, you place just cos of 4 and cos of 4 in degrees and radians, and then see whether you get the same what answer. Oh, someone was saying we didn't conclude. We didn't conclude, but since you can, kindly go on and conclude. You can go on and conclude. Shinazgua. Okay, I failed to get Regan.
Yes, teacher, please pardon me on what you said about finding maximum and minimum for tan.
Now you can never have a maximum or minimum. Have you ever looked, hope you looked at the graphs of tan. So
Yes,
when you look at tan has points of inflection. So it
yes.
doesn't have maximum or minimum.
Mm,
Yeah.
okay.
You can only restrict its domain and a range.
Yes. And then also, when we look at some functions like the secant and the cosec,
Mm.
do these also have the same maximum and minimum as sine and cos?
Does the cosec, sec, do they have the same? Okay. What do you think?
I see, like, since they are reciprocal to each other, maybe as I think it is supposed to be the opposite. Like, for example, for sine, maximum is 1. Then that
Mm-hmm.
means that for cosec, that 1 is actually its minimum, since they are reciprocal. Isn't it supposed to be something like that?
Mm. Now, uh, have you done curve sketching?
Yes. Only
You
one.
have done
Yes.
curve sketching, eh? So
Yes.
I'm going to just give you homework. You are going to sketch y is equal to cos x and sketch y is equal to 1 out of cos x.
Okay.
Then you'll notice that those two functions can't have the same maximum and minimum. So the structure of those graphs is totally different.
Okay.
Eh, so, but your answer is no. Eh,
They have.
yeah.
Okay. Thank you.
Okay. Okay. Let me know people are reading. Can I now first let you know? You start on the item. Start on the item now. Start on the item. Start on the item. Shinanzugua, you are not talking.
Oh, sorry, yeah. My audio wasn't being heard the first time. I was asking about the previous number.
Mm,
You stated that it would depend. It was depending on the exponential of 1 minus cos 3, exponential 1 minus cos 3t, cos 2t.
mm,
So what
mm.
if t was, let me say it was a function like 6t exponential 1 minus cos 3t. That means that t is also now in part of the coefficient of the exponential.
Come again. What if it was?
6t
Mm,
exponential
mm,
1 minus cos 2t.
mm.
So how would you approach that, since you now can't depend only on the maximum, of course?
Okay. Now this is where now your graphical analysis can come in. Because now here your y is dependent on t and this. So here you bring in the numerical approaches. Yeah. So you draw the graph and then you look at how it looks like. Okay. Let me hope members are trying. We want to know. I can tell you the answer. I think let me first pause the recording. Okay. Martina, take us through now. We start.
From the beginning.
Yeah, from the beginning.
Okay, so I first read through the scenario to pick some things. They told us that our H represents the height of the water above the ground, and T represents the time in hours, and then K is the positive constant. So it continues to say measurements showed that 10 hours after the leakage began, the water level. Okay, yeah, all that information. So what I picked was the initial height of water, which where we have T is equal to 0, is going to have a height of 3 meters.
Mm.
Then I said dh dt is equal to negative k exponential to the power negative 0.1 t. Then I put where k is less than 0, and then I said after 10 hours.
Have you integrated this?
Oh yeah, integrated it.
Okay, first take us through that.
So when I integrated, I just tell you the final answer I got.
No, take us step by step.
Okay, so what I did, I first separated the variables. Then I got h.
What did you get here? The h?
The h is equal to integral negative ke minus 0.1, sorry, negative ke to the power negative 0.1 t dt. Then I got my h is equal to negative k. I pulled out the constant, and then I put integral exponential negative 0.1 dt.
Okay.
Then I said when a is equal to negative 0.1,
Okay.
like I was trying to integrate that thing
Okay.
inside the exponential.
Okay.
Yes. So when I integrated the exponential, to be fast, I got negative 10 exponential negative 0.1 t.
Okay, you got 10 k
Negative 10.
exponential plus this.
Yes, plus c. But it was negative, not a positive 10.
Okay, how did it become a negative? What do you get when you integrate this?
So I was getting a negative because how I got it was 1, because I said 1 out of a, because remember I made my a negative 0.1. So I said 1 out of a times exponential a to the power t. So now if I fill in what my a was, it's going to be 1 out of negative 0.1 times exponential 0.1 times t. So when you say 1 divided by negative 0.1, you get negative 10.
Okay, then what about this negative here?
Oh,
This
so
negative
I've
that was
forgotten
out.
about it.
Okay. Okay.
Yeah.
Hope this is okay now.
Oh, wait, not sure. I did it in the end. Yeah, I did it in the end. I'm just saying. Because I later concluded and said h is equal to 10 constant e to the power negative 0.1 t plus c. Yeah. So that was like the general formula. Then I found the constant. So when I found the constant, I said when h is equal to 3, t is equal to 0, then I got my constant as, I substituted it into the general formula, and I got my constant as c is equal to 3 minus 10k.
3 is equal to?
C is equal to 3 minus 10k was my constant when I substituted it into my general formula.
Okay,
Yes.
let me go to this. So your h became 10k e negative 0.1 t, then plus your c, which was 3.
Minus 10k.
Okay.
Yes. So honestly, at that point, I got confused. So what I did, I just continued, but I got confused. So I said there was a point where they're talking about 10 hours, the water had fallen to 2 meters. So I put when t is 10, then the height is 2.
Okay.
Then I substituted to find the constant, but I got like confused a bit.
Okay.
Yeah.
Continue. First work out and we see where you're getting. I've substituted. So what shall we have?
So I took this positive 3 to the other side to get 2 minus 3 is equal to 10k exponential to the power negative 0.1 times 10. Then
What is it?
Okay, yes, 1. Yes. Then I got -1 on this side is equal to 10k. Then I put the 10k out, so I factorized it out. So I got 10k, open brackets, e exponential to the power -1 minus 1. Yes. Then I multiplied by -1 so that I could get k.
Come
Wait,
again?
no. I multiplied by 10. Yes, so that I
Where?
could get. Oh, sorry, what did I multiply by?
Okay. So what is e to power -1? Hope you know it is the same as this. So at this point, I'm going to continue. So this will be 10k. Now, when you have 1 out of e minus 1, members, this is the same thing as, remember your LCM is going to be e. So it's going to be e divided by e, which is 1 times 1, which is 1 minus e. So that means that in this position here, I can place in my answer as 1 minus e out of e is equal to -1. So at this point here, it means that you can remove this e by multiplying both sides by e. So you get -e equals to 10k into 1 minus e. So since you are interested in having your k, so you divide through by 1 minus e. So I divide by 1 minus e, divide by 1 minus e. So what are you going to have? We are going to have here our negative e out of 1 minus e equals to 10k. Now mathematically, when you look at what we have, this I can write it as negative e. Out of what you have down here, I can factorize it out 1. Then here, instead of having that, I can have -1, then plus e is equal to 10 of the k. So when you look here, the two negatives here, this negative and this one can cancel. So you remain with e out of -1 plus e equals to 10 of the k. So here you can write it in a good way, starting with a positive as e minus 1 equals to 10 of the k. Since you want k, you multiply, you divide by 10. So I get e out of e minus 1 is equal to the k. Now you go back to your equation where there is k here in this position, you put this. So that means that your h is going to equal to 10 times your k, which is 1 out of 10. Then everything is divided by e minus 1. Then e of negative 0.1 of t plus our 3 minus 10 times the k, which is 1 out of 10, e out of e minus 1. So you notice that the 10 and the 10 cancel, so you remain with e out of e minus 1, then times e negative 0.1 of t, then plus, you notice the 10 are going to cancel, so you remain with 3 minus, you are going to have e out of e minus 1. Now, when you reach at this point, you can now collect the like terms, but you know this is e to power 1, and this is e to power negative 0.1t. So mathematically, that is the same as 1 minus 0.1t out of e minus 1, then plus. Now here, you can use the LCM, that this is like out of 1. So you can deal with 3 out of 1 minus e out of e minus 1. So your LCM is going to be e minus 1. So e minus 1 times 1 is 1, then times the 3. So which is that? Minus the e. So you end up with 3e minus 3 minus e out of e minus 1. So 3e minus e is 2 of e minus 3 out of e minus 1. So that means that here you're going to remain with 2e minus 3 out of e minus 1. So that is what I had told you to obtain. So thank you, Martina. You tried up to some point, but that's how you were supposed to conclude. So when you look at it, you note that how does the negative come about? Like the negative, mathematically, is like when you have, let me say 1 minus 2 out of 3 minus 4. You can factor out this negative here. You can say I can put out negative. This one I make it negative. This one I make it positive. So when you open negative times negative is positive. Negative times this is negative. So it is the same thing. That's how you can factor out the negative. Okay, let me pick on, yes, Brian, and then John.
Good afternoon, sir.
Good afternoon.
Sir, I'm really lost with how you integrated the other function.
Which function?
The other side, when we had just started with separating the variables, then how we integrate.
How we integrated this?
Yes.
Do you know how to integrate e power t, dt?
Yes.
What do you get?
You get the same. E power t.
What about when I have integral of e to t? What do you get? Yes?
I'm confused.
Because now that means that you need to go and look at how you integrate exponentials, because that is also part, you might have covered that in integration, how you integrate exponential, because that is the knowledge we are applying here. That when you are integrating an exponential, get this one, integrate it. When you integrate that, you get 2. Sorry, when you differentiate it, you get 2. So I write 1 out of 2, then I write the original thing. Then I add a constant. So you have to go back. We looked at it, I think, in term 1, somewhere there, last year, I think. Look at that video on how we integrate exponentials.
Okay.
Yes, John?
Good afternoon, sir.
Good afternoon.
Yeah, teacher, I also had the same exact question. I had got disturbance on how you integrated that exponential.
Now, that exponential, when you have e of negative 0.1 t dt, you can let u equals to the power of negative 0.1 t. So when you differentiate this, you get the u is equal to negative 0.1 dt. Now, when I come here, I'll have integral of e. Where there is my power here, I'll put u. Then times dt, my dt is going to be du divided by negative 0.1. So that means that negative 0.1 is the constant. I will pull it out and I remain with EU du. But when you integrate e du, your answer is going to remain EU. So here you get 1 out of negative 0.1 e of u. But u is the same as this thing. So that means you get 1 out of negative 0.1 e power negative 0.1 of t. So that's how you integrate it. But 1 out of negative 0.1 is the same as negative 10. But since here there was a negative k, that means you say negative 10 times negative k, which is the 10k. So that's why here we have 10k.
Oh, thank you.
Okay. All right. So let me hope our members, we are getting there. Remember, members, we have not yet completed this. yes, so let me clear the screen. Now, we go to the next part. They wanted us to investigate how the water level changes throughout the linkage process and hence determine the position of the hole relative to the ground. Now, this is where you need to understand that much as the tank is leaking, they have asked us that what is the behavior? So you investigating how it changes with the leakage process, you are going to come in this equation. You remember how we tested. Then you start, when your t is equal to 0, what is your h? When your t is equal to 1, then you find. When your t is equal to this, what do you find? So that is how you are going to determine. But now, in the long run, you are going to ask yourself, what happens as the time keeps on going? Now, this is where reasoning is very important. That's why here I know you are going to say that as time goes to infinity, what happens? Now, that's where the understanding is coming. That's why they're asking what will happen. The devil as the linking process. So you need to know that in the long run, as the time, as the hours are increasing, maybe up to infinity, in the long run, what will be the height? Members, what do you think will be the height? Put for me your answer in the chat. As the time tends to infinity, what do you think your h will be? Place your answer in the chat. Now I'm seeing the answers. Now let's reason. We have to reason out. I know I'm seeing people are telling us that it is 0, but how does it become 0? Remember, the water, the tank will stop linking. Now, for you, just imagine you have your tank. This is your tank, and maybe there is a wall here. Right, the water is going to be moving out, but if the water reaches this part where the wall is, around here, that will this water shall we have you saying that h is equal to 0? It means that your tank has gone to 0. It means that your tank now has got empty completely. Does it mean that it will jump this wall to get to 0? So what does it mean? Now you reason again. Will our tank get empty? Remember the tank, everything we are doing, it is dependent on this linkage of the wall. That means that if your water decreases and it reaches this point where your wall is, the water is going to stop linking, going out. So your tank cannot go to 0. So your H can never be equal to 0. Now that is now the reasoning we need to bring out. As you attempt these items, so the limiting, that is where you studied what we call the asymptotic behavior. You remember when you are studying asymptotic behavior, now this is where the knowledge applies. That asymptotic behavior means that it does not touch much as it tends towards it. So that's why it is very important for you to know how to interpret. Yes. You need to know how to interpret what we call the limiting behavior, what we call the asymptotic behavior, and how to interpret this kind of models. So that is the kind of interpretation you needed to have. That here, my thing cannot equal to 0. So your tanker will not go to empty, will not go, because as long as the water reaches that linkage where the thing is, it will stop there and will not link again. So what are we going to do? Now you need to know that your H is dependent on this T here. This is the thing where the thing is that is going to depend. If you want, you can also come here that your exponential here, this one here, is what determines. You thought the hole is at the bottom. Hey, that's what you thought. Okay. Yes, even if it is at the bottom, I doubt whether your tank can ever, for you can try it, but you can look at at the scenario. You can look at the scenario. You read it very well. That's why always read the scenario to understand. They told that the small hole is located on the side of the tank. They never said it is located at the what? At the bottom. Hope that is okay, Andrew. It is on the side of the what? Of the tank. Hope it is okay, Andrew. Aha. Yes. So that one should be very clear. So I'm going to come back here. I was still telling you that this H here, the height of the water here, it will depend on this T here. These are the things we are looking at to vary. Yes. So you need to be very, very careful on that. That's why now you need to understand. Hope you have done something of this nature. So that means that as your time tends to what? To infinity. Because remember, your time is going to tend to what? To infinity. That's what we're saying, that in the longer run, as the time goes on up to around infinity, what happens? Now, you are going to know that as the time tends to infinity, this one, can I use this? I don't know whether I can use this or I use this. But because everything we are going to be doing is going to depend on this. So as you have here infinity, what is going to happen? I know when you were drawing graphs, you looked at the graphs of exponential. Let me say e power t. And you looked at the behavior of this kind of curves. When you are starting differentiation, I know your teachers might have taken you through how these curves tend to, or how they look to. How? So you know well that as the time tends to infinity, what happens to this exponential? What is the behavior of the exponential? Tell me in the chat what you were told or what you found out. That as the time tends to infinity, what happens to the behavior of an exponential function? You remember you did those curves. If you looked at differentiation, integration, you were supposed to draw them somewhere. Such that you know that now that curve is the curve that looks like this, that is the curve that looks like that. It increases rapidly. It is constant. What does it tend to? Okay. What does it tend to? It tends to 0. Very good. It tends to 0. So what does it mean? Now it means that the whole of this thing is going to vanish. So it's going to be like 0 out of e minus 1, then plus 2e minus 3 out of e minus 1. That is your h. So that means that now you are going to have your h equaling to 2e minus 3 out of e minus 1. Now, this is going to be the remaining thing, like the water, something like that, that will be remaining. So your tank will not empty to 0 as long as it reaches. So when it reaches, this is going to be the remaining height. Hope you have understood that. So that is going to be the remaining what? Height. Okay. Hope we are together. Any questions or you have picked something? I know it may be a bit new to some of you. So the remaining height will be around 6 point something. Yeah. So the moment, that means that this tank, the moment it reaches, when the height is around 6 point something, that means that that is the like when you compute this, that means that the arm, once it reaches there, it means that that's where the wall was located. Yeah. Now, what if the E is not given, but still you'll have the varying variables? You can even try to sketch to see how it behaves. Yeah. Yes, I know the concept. Okay. I think we are going to end here. We are going to end here. But let me give you one. Let me give you one here, such that you can exercise your muscles in the evening very well. Okay, hope you have taken a screenshot. So we are going to end here. So you'll practice. You are going to practice and see up to that point. Try to practice as much as you can. Yeah. I don't know whether this one I need to, yes, try to practice and try those items, but please make sure that you know how to interpret. Don't cram, don't cram, don't cram if you want to enjoy the math. Otherwise, if you cram those formulas here and here, here and here, things may not work out for you. So you need to understand the scenarios. You need to contextualize it. Make sure that that knowledge you acquired, you are applying it, not you just cramming it. I know when you look at the question banks, what, you may look at the questions that are a bit more direct without the context. Okay, someone wanted this. I want to just look here and see what this one wanted you. Oh, okay. Here, let me give you the answer because we may not have the time. Now here, they wanted you at the final thing to determine at which population reaches half of its limiting time. So if you get this answer, let me give you, if you get this answer, something like this, but you can get the decimals. That is what, let me say 2 divided by ln of 2, ln of that, times 2. If you get something like that, then that will be okay. Yeah, it will be okay. So you try, you do your best. Yeah. So tomorrow morning, God willing, we shall look at how now to model, how to come up with these kind of equations. That's what we shall look at in our session tomorrow in the morning. Yeah. More items. Yeah, I'll add you more. I'll add you more. I'll give you more in case my time allows. Yes. If Faith, I said if the whole of the thing was placed at the bottom, then that is okay. Your height would have reduced up to 0, but it was on the side way. That means that if, like, for you just have your bottle, if you place a hole, water will leak up to when I don't know up to what time. Then after some time, once it reaches that point, it stops. It stops. Yeah. And even here, this scenario, we can even make it better. I know we can put more mathematics and more context on it. Okay, I've given Regan. Okay, I've shared the question. Okay. Okay, someone has shared. Okay, the screenshot is there. Okay, no, like first prove your answer. As long as you prove your answer and you get that, then that is very good. Okay, so have a lovely day. I don't know. I think some people are not on the group. Let me share for you the link, those who are not on the group. But tomorrow we shall meet at 5 a.m. 5 a.m. is 5 a.m. We shall meet and then we'll look at a few scenarios when we are modeling how to come up with those equations and then we solve them. Where is the question? The question has been shared. So that is the link for those who are not in the group, who are asking for the group. Okay, have a lovely day. See you tomorrow. In case there's something you have not understood, I know you can catch up with the video